so I butted into this session. Thanks, Andy Hogg, for organizing this. So a lot of the talk is, should we CMIP, should we not CMIP, and we really need to resolve this. And I want to start with CMIP and end with CMIP, but really I want us to open our minds a little wider and ask the question, what does this nation need? And I think I would not say the nation needs CMIP, although it will, but the nation needs a thriving, active, and world-class modeling program, okay? And CMIP has given us that over the past few decades through the efforts that we've heard about at CSIRO largely, right? And it's been done on a shoestring, and they're not the only ones who are doing it on a shoestring. And trillion-dollar decisions are made. Trillion-dollar decisions around the world are made on stuff that half of which is done on a shoestring. Do we really want to be in that state still 5 to 10 years from now? I hope not. It would scare me if we do that. All right, so where I want us to open our mind, and then we can come back to CMIP, is so if we agree that our country needs to be able to design and run its own climate models, then why would we argue that, right? And we would argue because we want to be players on the international scene, and we've heard a lot about this, so I won't talk about this. But because the other reason we need it is there's science to be done that will lead into user needs and user information, that if we don't do it, the user information will not improve. It will just not get any better, right? And here are 3 science questions, which I picked from a paper I was involved in. Jakob was the first author. They're my favorite 3. How is the weather going to change? These are deliberately chosen to sound simple and be really, really hard once you dive in, right? Really, really hard. We spent 3 days coming up with those 3 questions. We did a bit more, but the key was to come up with simple sounding questions that people on the street can relate to. And this is one: how is our weather going to change as the climate's going to change? Why would you want to know? Well, you need to plan for adaptation. What are you adapting to? You're adapting to the weather. But no one has mentioned mitigation implementation. We have pledged net zero 2050. Now we need to make electricity 90% from the weather. The weather, not the climate, not extremes, the weather. Every day we need to make electricity. What do we know about our future weather? Not much. Well, we have a center of excellence that's meant to look into that a little bit more. The second question, where does the carbon go? Incredibly simple sounding question. All the processes on land and ocean carbon cycles are far from understood. So where it goes is a simple way of saying, how is carbon exchange between the spheres? How much can the planet store? How much, how can we manipulate that storage in our favor or not? Can we manipulate it? And last but not least, what does it mean for people and not just humans, actually, to the livability of the planet? And I've sort of written down what kind of models one would use to help answer these questions, right? So the carbon is obvious. You need an Earth system model. We've heard about this. Global models need to have higher resolutions to do the weather part. That's where the high resolution comes in. Livability, if we think about humans, we want to look at cities. Well, who's going to build these models for Australia? The UK? I doubt it, right? So I think we really need to have and maintain this capability. And I think CMIP has been a very successful vehicle for us to do it. So we need to continue to use this vehicle until we have the strength in the community where we can actually rely on this. I think it's really science questions, user needs. And then there's technological capabilities. We heard Ben talk about that. Computer says no most of the time, right? On what you want to do. And then you talk to Ben, and then you do the best you can. And you pick the resolution that you can just about afford, and so on and so forth. But this technological capability is equally critical to the success of the enterprise. And if we didn't have NCI becoming a de facto, having at least a part that's de facto the nation's climate modeling facility, climate computational facility, most successful countries, by the way, since we have lots of people in the room, most successful countries in climate modeling have dedicated climate modeling climate compute facilities. And Ben is our dedicated climate compute facilities, even though NCI has a wider remit. Okay, now I was meant to talk about high resolution, and I don't have much time, so I'll really rush through this. So we've accepted warming targets. We need to implement them in Australia. So there's no point running a model over the UK because we need to implement our contribution to this. So we need to know what the weather in Australia is. over the next decades and beyond, right? That means, how does climate variability interact with the weather? How does climate change interact with the weather? How does climate change interact with variability? We've done quite a bit of work on that already, but how does that feed back to weather systems? Then we need to translate that into what actually matters to people. Wind power, high impact events, right? There's your picture of a high impact event. We do this with models mostly, entirely, right? So we need to have the capacity to at least understand the ones we are given, and also adapt, improve, and build them for our purposes here in Australia. This requires a massive shift in more than one paradigm. Resolution, we've already talked about, and I show you some pretty pictures in a second. Data assimilation is not much talked about in Australia at all, but we really need to also know what is the state of the system right now at any given time. And not just the physical system, but also the human systems that connect to it. What do they look like? One of the things that will come down the pipe, which we are ill prepared for, is even technologically, the applications, the impacts models, the decision-making models, need to be directly integrated into the workflow. You know why? Because once the models have high resolution, we cannot store the data and give it to someone afterwards. That paradigm is dead. In 10 years' time, no one's going to do that anymore, right? So the application models need to run in the same workflow. They don't need to be part of the climate model, but they need to run in the same workflow in parallel with the climate models. We need to get prepared for this. This is going to be a big task. It needs to be funded, or we're going to fall behind the rest of the world. And so really what we want is this digital copy of the Earth that we talk about in the WCRP Digital Earth program most of the time. Okay, a bit of eye candy. What could we gain from these high resolution? And it's really just eye candy. So this is a pretty picture. And had I not said which is which, you probably would have struggled to tell me which is the satellite image and which is the forecast from the ECMWF model at 2.5 kilometer resolution. So this is a forecast. This is actually not a climate simulation. I promised Andy I'd show this, even though it's not MOM. So this is a 3 kilometer simulation over the Southern Ocean with a model called FESM, which is run in Bremerhaven in Germany. Nikolai Koldunov, thank you for giving me these movies. It made the presentation unnecessarily large, but it's very pretty. So I run this one more time. So there are ocean eddies, there's the sea ice in that model around Antarctica. So very nice. These are the only Southern Hemisphere examples I could find in anybody's slide from a 1 week workshop. Most people concentrate on the Northern Hemisphere. What does that tell us? What does that tell us? If we don't do it down here, no one will. Here's a bit beyond the eye candy. So there's some good news that if you increase the resolution, precipitation extremes will get better. There's bad news, 5 kilometers not enough. 1 kilometer is the number when it starts to get really good. Rainfall associated with tropical waves. Once you get to 3 kilometers, that gets much better than in a 15 or 30 kilometer model. So there's hope. There's bad news too, which just tells us we have our work cut out. These are 5 kilometer coupled runs at the top and limited area models at 2.2 kilometers. And this is the rainfall error. And for those of you who have looked at CMIP models for all your life, you will recognize it looks exactly like a CMIP model, which means it looks really bad. Because they're really bad at doing rainfall, even the climatologies. There's a horizontal SPCZ, there's a cold tongue. Every favorite error you find in a 150 kilometer model, you also find in these 5 kilometer models still at this point, which means there's no automatic sort of improvement of everything. But it's a lot of work to make these models work. But we need them because if we want to simulate the future weather, these things scale up to the weather scales, right? These small scales that we are now resolving, especially convection, scale up to the weather scales. I'm going to skip over this. And I want to take this discussion a bit further than just CMIP, right? So CMIP to me is the vehicle that we need to have a modeling program at all. If we drop CMIP right now, we will not have a modeling program. And then we cannot do all these things that we need to do and that the nation expects us to do. So to me, that's a bit of a no-brainer. But we need to maybe it's easier to sell that case if we think further than just CMIP and actually include science questions and user needs as our first and foremost drivers, right? And then say CMIP is the vehicle that will achieve this in the short term, and then what we do in the long term, let's sit down and debate it. We should really take advantage where CMIP fits in on everything we do, and we should also put our work into CMIP wherever it fits, right? So to me, that's the no-brainer part. So we'll do the weather question in this COE, but to do that, we need high-resolution models. To have high-resolution models, we need modelers. We don't have any modelers anymore. There's no atmospheric modelers. You heard it from Martin, contributed to CMIP6. That's really bad. That's really scary. We need to build this up again. And it needs to be done soon, because if we wait another 3 years, then it's gone, as many people pointed out today. And we really need to be smart about this and exploit as many avenues as we can. To me, the mission is to make this nation successful in modeling, right? And CMIP is a critical component to this, but it's not the only thing. We really need to do more than just CMIP, but we absolutely need to do CMIP. So there's my 2 cents of contribution.
Great. Thanks, Christian.